Welcome everybody. You're watching Mr. Fugu Data Science. Today's an introduction to RStudio for someone who's never used it before or trying to get their feet wet. Before we get started, I'd like to say thank you to the new subscribers and recent viewers. I greatly appreciate it. Let's get into the basic console. Here we are. This left pane that you see here where the cursor's moving around, this is called your source pane in the left top column. The next one will be called your environmental pane. This is storing my environmental variables I've used in the past for previous scripts and markdown files. You have a history of commands that you've used. You have connections, and then you can look at a tutorial right here. Okay? You can also look inside of these and figure out for each one, for instance, like a data set, you could figure out what the data looks like. Okay? To get like a glimpse. We have the lower left right here, which is a console, similar to if you're using the terminal here. If you're doing commands, you can run the same thing. If you notice, I did a factorial. I looked for my working directory. You can also run a question mark, and then if you have a specific function you're looking at using, it'll pop up here on this lower right, and it'll tell you basically the functionality, what options you have, what are the parameters. So if you are unfamiliar or you forgot, hey, how does this exactly work? What are the arguments or parameters I need to throw in? It'll give it to you right here, similar to if you were doing help. Okay, you have files right here, and that's for basically looking at what's inside of your machine if you're trying to locate something. If you had a plot that you just did, it would show up here. You have packages. You can do updates. If you needed to install something, you just click this. And then if you just had some random name you were looking for, you can find it here, click it, do an install, okay? You can also use the help function. You can go back in the console. You can also do install packages here and then put your package name. It pops up and it'll give you an idea of how you fill this out. This is another option for running packages. This upper left, since I have it as a markdown file, if you're creating a new file or project, you could do a script, a notebook. I usually work with notebooks or markdown files just for illustrative purposes. And you have multiple outputs that you can do for files. All right, let's get back to our notebook that we're working with. You could cut and paste all of the same functionality into RStudio that we're doing. So as you saw, we could get a working directory. We can also set a working directory. We can assign variables, obviously. Let's set something in pretty basic just to get an idea of what you can do. I'm using this weird little arrow, so you are basically creating like a pointer, I would think of it, in order to store our variable. So as you see, we can assign our variables. We can also do some rounding. So let's figure out, all right, we need to round this because obviously this is too big. At this point, we don't need this many decimals, right? So we could say we need 4 decimals. And so it prints out right here. We could have also just did the same thing so you have an idea. If you ever are curious about what's going on, just do a tab or shift tab if the tab doesn't work, and it'll pull up other options that you have for your functions. Okay, we can do a truncate. So this truncate this. We can also do the floor. So we're doing a rounding down. We can do the ceiling. We can round up. We also have the ability to replace a function or a variable. So then let's just create a vector and we'll just put a bunch of zeros. So it's nothing useful, right? But I print it out so we can see what's going on. So let's replace the third entry for our old with, I don't know, let's say yay. So we just replace the third entry right here. Here's the basic syntax for a vector. So what's going on with this? Let's create our first little vector and let's store in it. Let's just make something up. And from here, we can notice that it'll default to the weakest type, right? So what's really going on with this? Here's our first vector that we're printing out. Let's see what's going on with this defaulting to the weakest type. So let's create a mixed type for the vector and let's see what happens. Notice that everything's surrounded by a string, okay? So that's something you should take into consideration for these, all right? We could write sequences, create a sequence vector, and let's just do something simple like a range value. And then let's decide to do this range, but do it a little bit differently. So let's do something like, so we'll call it a sequence function. And what are we doing? We're doing from 5 to 9, stepping it up by 0.6. So let's see what that looks like. So here we are, we're starting at 5, we're going to 9, we're stepping by 0.6. Let's specify a length of what our vector is going to look like. So let's do, I don't know, from 2 to 8, where we have a length equal to 9. Okay, so we're going from 2 to 8 where we have 9 entries. All right, we have repetitions that we can now do. So this, call the repetitions, which would be REP, and then let's just put in some string where I love data science. Okay, fair enough. So what are we going to do with this? Let's make a repetition of this. So let's repeat this twice. So think of just concatenating. That's what's going on with this one. So let's try this again, a little different. So instead of this 2, let's customize this so each one of the strings has its own specific format. So then we can see that I is replaced only once, whereas love is twice, 3 times for the next or 2 strings. Okay, we can do vector operations. We're just going to look at simple things right now. So let's just look at multiplying our vector. We can, so you can see what the original looked like. There you are. We can also access values within our vector. Oops, let's step back. We can also, I'm going to play around and do more to this. Okay, we can do accessing of our vector, for instance. We can do other variations where we can take like a range if we wanted. We can also do it like this, where you're taking an array of very specific entries. Let's just say like that. So we could take these entries. We could do Boolean expression comparisons. So let's do our first comparison of a vector, and that's called the sequence vector. Okay, and then now let's see what's greater than 16. Oops. Now we do our comparison for a Boolean expression. But what happens if we wanted to actually print out the values that are equivalent to true, instead of just noticing that this is a true-false statement? Then we can do this, where let's just call this the comparison vec, and then we call in our vec where we basically cut and paste this in, and there you go, there's the values that equate to being true, which are greater than 16. We do some simple plotting. All right, let's just call some variable v3. Let's take in a sequence from 1 to 3 with a length, I don't know, to 10, and let's plot v3 with v3 squared. Okay, that's fine. But what if we're unsure what options we have for plotting? Now, if you notice, it just prints out the default scatter plot, and we can look at all the parameters that are inside of this, and we can read up on it. All right, we can do a tab. We could create our labels and our limits. Do whatever you want. Create a legend if you needed that at the time. We could do a simple bar plot. And let's take in v3. You do the same thing again. Tab or shift tab. We can create our limits. We create a title, etc. As a side note, we could do histograms and other natural plotting. In addition to the base R plots, you also have ggplot and ggplot2, which are commercially used for literature and presentation formatting. We can create equations and functions using latex formatting, such as this, where we're using the $sign, and then you see the slash and then the sum and then the underscore. Okay, so that's some of the formatting that we can do. So let's try some other ones so you can just get an idea. See, you can get a mu, etc. We can do some basic probability and statistics. So for instance, if we're looking at an R unif or runif, which would be, the R denotes the randomness, we can do this, figure out what's going on, what options we have of this class of this family of functions. Here's the density one, probability, quantile, etc. You can read this, figure out what your input needs to be, read up on the details of how it works. Let's do our runif, and let's say that we're going to create a uniform distribution from minimum of -1 to 1, where n equals 100. All right, and then let's name that our uniform sample, and our uniform sample will, let's print off the first 10 entries so you see what's going on. So here's the first 10 entries, but let me show you something. Notice that it's changing each time. We're going to have to take care of that if we're going to have repeatability for our data. Let's do a simple histogram of this real quick. So here's the histogram of this real fast. As always, you could change the labels, your axis, anything else you want. If we're going to have repeatability, we need to do something called setting a seed. I'm just making up a random number for the seed where we're going to have n equals 100, where we have 60 as the mean and we have a standard deviation of 5. And let's look at 3 through, 10 entries. Let's run this again, and you notice this stays the same, which is great. So let's create our normal distribution, and let's cut and paste what we just did here, and then let's do a histogram of that. So here's a histogram of it. We can, like I said, do a question mark to find anything that you're looking for. But let's do a actual distribution now and look at what that would be, like a density plot. Let's just create a sequence where we're going to have 50 to 100. And we're going by steps of 0.2, and let's do a Y where we're having our D norm, which will be our density norm. This will basically show you what it looks like for the area under the curve. That's how you can think about this, with a mean of 90 and a standard deviation of 12. And then let's do some plotting of our XY, and then I'm going to put something that says type equal to L, and that just means I want a line. All right, so here we go. And you could play with this and see what it looks like when you start shifting these over if you actually wanted to get a standard or a visual representation of what this looks like, right? Here's us playing around with this a little bit, but anyways, we could do matrix operations, but I'm just going to show some basic ones today. So just pay attention here because there's something interesting you should see, and I'm going to point it out. So let's make our first matrix, and what we need to do is call in, you guessed it, matrix, and let's throw in our data, and you have two options here. You can do by row or by column. Here I'm just going to do by row to feed in my data, and I'm going to have n rows equal to 3, and then what if I just leave that? Okay, it knows if I specify the number of rows how many columns to give us from the data that we have. The thing I wanted you to notice is right here, this 2 is recycled because basically I'm calling in by row, and since this isn't available, it recycles and uses this 2 again. So you need to be careful of that. What if I said by column? Then we would have been all right. So you need to pay attention. This is what I just mentioned right here about our paying attention. If you only place in the rows, it'll figure out the columns, etc. I think it works the same way in the reverse for columns. So let's do some accessing of some elements, and let's do some playing around, all right? Let's create a pretty long little vector so we can do some playing around with. Let's just copy paste that again, and create our second matrix. Let's call in our DTA, and let's get that. Now, what else are we going to do to play around with this? So here's what it looks like. Let's do some accessing. So let's do the first row and the first column, or excuse me, column 2, row 1. So that row 1, column 2 is the 6. We can take everything from column 1. Let's take all rows from column 1, and that's the 2, 3, 4, 5. We could take a range of values, which would be, let's do 1 through 3. So rows 1 through 3 in all columns. What you have here, we have specific rows or columns that you can do, and let's do both to play around. So let's do row 1, row 3, column 1, column 4. And that's what we have here. We have the ability to find out the dimensions of the matrix, so it's a 4 by 4. We can do descriptive statistics, such as finding the mean, the median, as well as the standard deviation, which is shown here. I would like to say thank you for watching. Please like, share, and subscribe. And if you subscribe, turn on that notification bell. I also left a few useful tutorials that I would suggest looking at to help you get started in your new adventures using RStudio. Thank you for watching. I'll see you in the next video. Bye.